a deep dive into buffer overflows vulnerability in SLmail 5.5. Héctor Borges, Jorge Vera, Alexander Castillo. Project presentation. Malware analysis is a critical task in cybersecurity, involving the identification and understanding of malicious software. Buffer overflows vulnerabilities are a common type of security flaw that can be exploited by attackers to gain unauthorized access or control of systems. This research focuses on SLmail 5.5, a popular email server application, to investigate its susceptibility to buffer overflows vulnerabilities. The objective of this research is to identify and analyze potential buffer overflows vulnerabilities in SLmail 5.5. The scope of this research will include identifying vulnerable components and functions between SLmail 5.5, developing and executing exploitation techniques to exploit identified vulnerabilities, assessing the potential impact of these vulnerabilities on SLmail 5.5 users, proposing mitigation strategies to address the identified vulnerabilities. Buffer overflows occur when a program attempts to store more data than its allocated memory can handle, leading to data corruption and potential security vulnerabilities. Stack-based overflows target the function called stack, while heap-based overflows exploit memory allocated on the heap. Attackers use various techniques to exploit buffer overflows. Code injection involves injecting malicious code into the program's execution flow. Return-oriented programming reuses existing code fragments to execute arbitrary instructions. To mitigate buffer overflow risk, developers employ techniques like canaries, which detect stack-based overflows, and address space layout randomization, which makes it harder for attackers to predict memory allocations. Additionally, safe memory allocation practices and input validation can help prevent buffer overflows.
SLmail 5.5 is a popular email server application that provides various functionalities, including email reception, storage, and delivery. Understanding its architecture and its functionality is essential for identifying potential vulnerabilities. Identification of vulnerable functions. To identify vulnerable functions or code sections within SLmail 5.5, a thorough analysis of its source code and network traffic is necessary. This involves examining functions that handle user input, data processing, and memory allocation. Detailed analysis of the BOF vulnerability. Once a potential buffer overflow vulnerability is identified, a detailed analysis is required to understand its root cause and exploitation scenarios. This includes identifying the vulnerable function, pinpointing the specific function or code section where the buffer overflow occurs, analyzing the input, determining the type of input that can trigger the buffer overflow and the conditions under which it occurs, understanding the impact, assessing the potential consequences of the vulnerability, such as remote code execution, privilege escalation, or denial of service. Root cause analysis and exploitation scenarios. A thorough root cause analysis will help determine the underlying factors that contribute to the vulnerability. This may involve examining coding practices, memory management techniques, and input validation mechanisms. By understanding the root cause, it is possible to develop exploitation scenarios that demonstrate how an attacker can exploit a vulnerability to gain unauthorized access or control. These scenarios can be used to assess the severity of the vulnerability and guide the development of mitigation strategies. To demonstrate the exploitability of the identified buffer overflow vulnerability in SLmail 5.5, a proof-of-concept exploit can be developed. This exploit will simulate a malicious attack by sending specially crafted input to the vulnerable function. Step-by-step explanation. The exploitation process will involve identifying the vulnerable function, pinpointing the specific function that handles the password input, crafting malicious input, constructing a carefully crafted input string that exceeds the allocated buffer size and can overwrite the return address. Sending the input, transmitting the malicious input to the vulnerable function via a network connection. Observing the system's response, monitoring the system for any signs of compromise, such as an unexpected behavior or execution of malicious code. Impact analysis. Once the exploit is successfully executed, it is essential to analyze its impact on the system. This includes unauthorized access, assessing whether the attacker can gain unauthorized access to sensitive data or system resources. Remote code execution, determining if the attacker can execute arbitrary code on the system. Privilege escalation, evaluating if the attacker can elevate their privileges to gain more control. Denial of service, assessing the potential for the exploit to cause a system to crash or become unresponsive. Potential consequences. A successful exploitation of the buffer overflow vulnerability in SLmail 5.5 could have severe consequences such as data theft, sensitive information such as email content and user credentials could be compromised. System compromise. The attacker could gain control of the system and use it for malicious purposes, such as spreading malware or launching further attacks. Service disruption. The vulnerability could lead to service outages or performance degradation.
So what are the mitigation strategies? To demonstrate the exploitability of the identified buffer overflow vulnerability in SLmail 5.5, a proof of concept exploit was developed. The exploitation process involved crafting a malicious input string that exceeded the allocated buffer size for the password field and sending it to the vulnerable function. Upon successful execution, the exploit could lead to remote code execution, granting the attacker unauthorized access to the system. This could result in data theft, system compromise, or service disruption. Understanding the exploitation process and its potential consequences is crucial for developing effective mitigation strategies. Finally, in this research has identified a critical buffer overflow vulnerability in SLmail 5.5, demonstrating the ongoing threat of these attacks. The findings highlight the importance of thorough code analysis and security testing to prevent such vulnerabilities. The implication of this research extend beyond SLmail 5.5. It underscores the need for developers and security professionals to prioritize buffer overflow prevention in their software development practices. By understanding the techniques used to exploit these vulnerabilities, organizations can implement effective countermeasures to protect their system. Future research directions include exploring additional vulnerabilities in SLmail 5.5 and other similar applications, developing automated tools for detecting buffer overflow vulnerabilities, and investigating emerging exploitation techniques. By addressing these areas, the cybersecurity community can stay ahead of evolving threats and ensure the security of critical systems.